this problem we have that calcium carbonate is heated to produce calcium oxide and carbon dioxide. Calculate the number of moles of calcium carbonate that must be decomposed to produce 0.4 kilograms of calcium oxide. So we have this expression. We can see that this is a reactant, and this here it says is heated to produce. So these two will be the products. Now this expression is already balanced. So now we use the DREAM tool to get the answer. So in data and recheck, we have the mass that is given to us in the problem, and we have the molar mass of calcium oxide, that is 56 grams per mole. Now that we can get in the periodic table with the masses. And now we have, and we need the number of moles of calcium carbonate to produce 0.400 kilograms of calcium oxide. This is what we want. Now in the analysis, first we convert kilograms to grams, this kilograms to grams, then convert grams of calcium oxide to moles using this formula. Then use a conversion involving calcium oxide and calcium carbonate. And remember, we need to have everything in moles so we can use the conversions. Now here in the math we have step 1. So we convert kilograms to grams. Here we did the conversion. In step 2, here we have it, the formula, and we arrange the formula so we could have the moles. So now here we have the moles. And finally, the third step, we use a conversion involving calcium oxide and calcium carbonate. So we arrange, and we can find these conversions using this expression right here. So we have that we have 7.14 moles of calcium oxide times 1 mole of calcium carbonate over 1 mole of calcium oxide, and we arrange them this way so we can cross out these two. So finally we have the result that it will be 7.14 moles of calcium carbonate. And that's how we do this problem.
This problem is telling us that we have sodium and chlorine, which reacts and produce NaCl. It is asking us to calculate the number of kilograms produced of sodium chloride if 230.1 grams of chlorine had reacted. The first thing we're going to do is to balance the equation. So here we have that Na plus Cl2 react to NaCl, but balance is that 2 moles of Na plus 1 mole of Cl2 react and produce 2 moles of NaCl. Here we have the proportions. 2 moles of Na equals to 2 moles of NaCl, and 1 mole of Cl2 is equal to 2 moles of NaCl. And we have that the mass of Cl is 230.1 grams. So next we're going to our end, that we are ending with kilograms of NaCl. Then we make an analysis, and we know that we have first to get molar mass of Cl2 from the periodic table, then get the moles of Cl2 using the formula of molar mass, and because it gives you the mass in the problem, and then convert to kilograms. So in the math we have the molar mass of chlorine, which is 70 grams per mole, and we get the moles of chloride, which is 3.28 grams. Then we get the molar mass of NaCl, which is 58 grams per mole, and then we have to get the moles of NaCl. To get that, we have to multiply the moles of CO2, that is 3.2871, and multiply to 2 moles of NaCl and divide it with 1 mole of CO2 to get the balance. So that gives us the moles of NaCl, which are 6.56. So with that quantity, we get the mass, and it gives us the molar mass of NaCl, that is 58, multiplied by 6.56, that is the moles of NaCl. So we get the mass of NaCl, so it is 380.48 grams. And now we have this, we have to convert to kilograms. So we have that 1,000 grams is 1 kilogram. So we divide 380.48 by 1,000, and we get that we need 0.38048 kilograms of NaCl. And this was our problem 5. Thank you.